So we just got done doing multiplying monomials, and in some of my classes we did an example with the box, and y'all seem to really like that. So just as a reminder, what we did was we took, oh my gosh, those 2's, 2s, 3s minus 1, and then we combined them this way. So we expanded them, we regrouped them, 3 times 2 is 6, we got our coefficients, and then we multiplied our s's. And then we did the same thing here. We multiplied our coefficients together. Negative 1 times 2 is negative 2. And then we had 2 s's. So it ended up being 6s to the third minus 2s squared. We're going to use that same principle, the expand, reorganize, expand, regroup, compress. We're going to use that same strategy when we divide monomials. I want to remind you of something else that we did in our last video. We talked about area and dimensions. So remember, we talked about how dimensions are on the outside and area is on the inside. Factors are on the outside, product is on the inside. This is going to matter because a lot of times the application that they give us for this is they'll say, well, the area of this shape is something, and the width is what? Is some number. What's the length? So they'll ask us, they'll tell us that, so like for example, on this one, they tell us we have the length and we have the area. We need to figure out what the width is. Okay? So that's kind of like the most common like real world application of this that we're going to see when we're doing this dividing monomials. They'll ask a lot of questions about area. So what this means is, the reason I reminded you that the area is on the inside is because what I'm going to do is literally I'm going to write the area on the inside. And this is kind of hard to see, so I'm going to write the length on the out. So I'm looking for this one. Well, normally to find the inside, I multiply the dimensions to find the area. Well, if I know the area on one side, I'm going to work backwards by dividing. So that'll look like 15m squared divided by 3m. Well, in algebra, we don't write things like this. In algebra, we always write them as numerator, denominator, kind of as a fraction, because algebra depends on a lot of canceling. So the way we would officially write this problem is we'd write 15m squared over 3m. That's how we would write this division problem. Okay? So our strategy is the same. We expand, we cancel. When we expand, we regroup, we cancel, and then we compress. So let me show you what that looks like. First thing we do is we expand. And we expand everything, including the coefficients. So 15 is the same, and I look at the denominator to give me a clue. I look at the other part to give me a clue as to whether or not I need to expand it. I know I need to expand it because 3 goes into 15. Well, 5 times 3 is the same thing as 15, so I'm going to expand it that far. Times m times m. So I expanded the top. Now I'm going to expand the bottom. And I try to line them up so that they go with the part they're with. So the 3 matches up with that 3, and this m matches up with that m. So I've expanded now, and I've regrouped. So I kind of regrouped while I was expanding. Now I'm going to cancel. Well, I have a 3 on the top and a 3 on the bottom. They cancel. I have an m on the top and an m on the bottom, so they cancel. Well, now I'm going to compress them back together, which is 5 times m over, well, there's nothing there. So it's over 1. When I put that together, I get 5m. So my missing side length is 5m. All right. So that's a lot of talking about it. Let's actually do another problem. I'm going to do one, and then I'm going to let you guys do one. Actually, I'm going to do this one, and then I'm going to let y'all try this one. Okay. So for our first example, I start by writing it as a fraction operation. Okay, so I have 35, because this is the area, and that's the side length, and I'm trying to find this missing side here. 35 u to the 4th v squared over 5 u squared v. Okay, so I'm going to expand it first. Well, I see there's a 5 there. 35 is also 7 times 5, and I've got 4u, so I'm literally going to write u, v, because there's 4 u's being multiplied and 2 v's. I divide. On the bottom I have a 5. U squared is u, and then I got a v, so I'm going to scoot it over there under the other v's so that I can cancel them out. That's not a minus. The u's cancel here, this 5 cancels, and this v cancels. So what's left? Well, I have a 7, and then I've got 1, 2, u squared v. It's over 1, but do I have to write over 1? No, I don't. I want y'all to take a minute, and I want you to try this one and see how it goes. Tell me what your final answer is. So again, you're going to take x to the third y squared z and divide it by xyz and tell me what you wind up with. All right, so you should have started with x to the third y squared z over x, y, z. So we first write it as a fraction. Then we expand. I have x to the third is x, x, x. Y squared is y, y. There's only one z, so I put that there. On the bottom, I put x, and then I have a y, and I have a z. And again, I'm lining them up so I can cancel. These two x's cancel, those two y's cancel, those two z's cancel. What's left? Well, I have x squared y. Okay? This problem here is the same exact thing. I want you guys to try this one too. Again, we're going to expand. We're going to write it as a fraction, expand it, group to cancel, cancel, and then compress it back together. All right, so the area is 12, a to the third b, over 6a squared. So I'm going to expand that. I see there's a 6 down here. Well, 12 is 2 times 6. I could have said 4 times 3 or 2 times 2 times 3, but I know I'm going to be canceling a 6, so I don't have to do that. I kind of like, I factor smart, okay? So I expanded that. I have a to the third, so that's a times ab, and then I have 6, a squared is aa. So the 6 and the 2 a's cancel, and what's left is 2ab. Now some of you may be asking, like, why are we doing this? I want to show you an example where expanding like this matters. So what if we had, let's say, 3a squared b squared c over 12a b squared. Okay? So I'm going to expand. I have 3a, b, c over. Now, I have a 3 up here, and I need to cancel. Well, 3 times 4 is 12, so I'm going to put 3 times 4, and then I've got a, b. There's no c. My 3 cancels, an a cancels, my 2 b's cancel. Well, what's left? I have a squared c on the top, and on the bottom, I have a 4. That's the answer. That 4 has to stay on the bottom. If I had an extra b on the bottom, it would stay on the bottom too. Okay, we're going to see a lot more like this when we do our exponent rules, but this is why this expansion step right here is going to help you out a lot. It's also going to help you when we do factoring in the next unit. So come in with questions if you have them.